Okay, this is video on SPSS number 5. Okay, last time we have discussed about graphs. This time there were some graph as homework, these ones. Let's, for example, start doing this one as an example. Okay, first of all we need to open the file. It's example data all with SPSS 18. Let's take a look at the file, at the graph. It's a graph of year of birth. It's an histogram. It's an histogram of year of birth, basically. Okay, but the histogram is rather particular because the bars of the histogram have the degree course splitting. Okay, so let's do it. Graph chart builder. Pay attention, it's an histogram and not a bar plot, because year of birth, it's a scale variable. You can see also the bars are sticked together, there is no gap between the bars. So histogram, it's this one. Okay, year of birth here. The set color is done by degree course. Let's see the other features. Green backgrounds, these are all features which can be done later. Well, it seems to be okay. There is a normal curve, display normal curve, apply. It's this curve here, this one. Okay, let's see the histogram. This is the histogram, double click to edit it. Okay, first of all, let's see the features. Vertical axis with steps of 5. So scale, measure increment 5, apply. Okay, well, just let's remove this point 0, number format, decimal places 0, apply. Doesn't work, it refuses to work. This is one of the typical little problems of SPSS, that sometimes it refuses to do something. Okay, there is no way. Green background, let's click on the background, green, apply. Let's put a lighter green. Stacked histogram, it's a stacked histogram. A thick red normal line, so the normal line, which is this one, is thick and red. Red, apply, and thick. Apply. Horizontal axis from 1950 to 2000 with steps of 5. So 1950 to 2000 with steps of 5. Apply. Okay. Horizontal axis value aligned horizontally. This one, they are already aligned horizontally, but just to be sure, number format, labels and tick, display label, label orientation, horizontal, just to be sure that they don't change while you change the graph further. No vertical axis titles. So you can simply press Enter to remove it. Oh, it doesn't work. Let's see. Text and display access titles. Okay, so here it's much better. Okay, let's remove also all this stuff here with Enter this time, which is not necessary. Let's try to make it as similar as possible. Let's put the legend inside. Is there any size in centimeter, categories, variable? No, we have to manually move it. No, not this one, the entire legend. Let's see, we can move the entire legend. No, there seems to be no way to move the entire legend. Legend is only required. Let's try to move it in this way. No, it doesn't move. double clicking on the legend, no, clicking on the legend. Is there any way to move it? No. Okay, let's leave the legend where it is. We can toggle it on or off. Ah, yes, now I think we can move the legend. No way to move it, let's leave it there. Ah, yes. Oh, finally. Okay, I think the graph is very similar to what is requested. As you can see, SPSS has some minor bugs which cannot be fixed. For example, this point 0, there is no way to remove it. We can try again. So number format, decimal places 0, apply, no way. Okay, we have to keep it close, and here you have your graph. Another quick example, for example this one. Passed exams by favorite subject. Okay, so it's a box plot, it's evident. Graph chart builder. Box plot, box plot. It's this one. Passed exams. No, here, passed exam. Favorite subject. Okay. Now let's edit it because it needs many modifications. First of all, twist it. So where is the twist? Here. Transpose chart coordinate system. Okay. Then we need the blue background. Apply. Orange boxes. Apply. Red, bold, large, vertical axis value labels. This one, red, bold, bold, and large. So let's put them large first of all. Size automatic, style, bold, apply. No vertical axis title. Labels and tick, display axis title, apply. No known and statistics categories. So you just click where you want and you search for the categories, usually clicking on the box categories. Okay, so known, remove, and statistics, remove. Apply. Okay. Horizontal axis from 0 to 50 with steps of 5. Scale 0 to 50 with steps of 5. Apply. Expanded boxes, so these boxes, let's start to expand them. Okay. Any other request? No. Oops, where is it? I lost the chart. I really lost the chart. Here. File, close. Let's look at the output. Oh, sooner or later, it's not a bad idea at the exam to save the output. Remember that the output file is a different file, so save as. Let's save it on my desktop as output 1. Okay. And here the other one. Okay, let's go on. Is a variable normally distributed? This is one of the typical statistical questions because normal distribution is a prerequisite for many tests. We don't go into the details of which tests require normal distribution of the variable and which don't, and on what is exactly normal distribution. Normal distribution means practically that the histogram of the variable looks like a normal curve. Okay. How to check it with SPSS? Well, you can check, obviously this applies only to scale variable. There is no reason to check whether nominal variables are normally distributed. It doesn't make sense. How to check it? Well, the first and easiest way is to draw the histogram and plot above a normal curve with the same mu and sigma as your distribution, but this is a technical detail. SPSS will plot it automatically. And Z, with your own judgment, so it's a subjective judgment, whether the normal curve and the histogram look more or less the same. Let's do it. Draw chart builder, reset histogram. For example, let's check whether year of birth is normally distributed. You put it here. Display normal curve. Please, at exam, if you are building the histogram because you want to check for normality, you must display the normal curve. Otherwise, do not display the normal curve. I will mark as an error whenever you draw an histogram which does not need the normal curve and you plot the normal curve above, just because you have forgotten it here. Okay, so please don't leave it checked always. You can check, you can see it immediately whether it's present or not. Plot it only when it's necessary. Okay, well, let's restrict as usual this row, thanks to the person scale 1950. Okay, is it normal? Well, I would say no, because this bar is too high. Okay. It should arrive more or less here. Here it's empty, so all what is here should be here and here. So it's too narrow as a distribution to be normal. Okay, so from this first qualitative test, it's a qualitative decision, it's not normally distributed. Let's see other way to check whether it's not normally distributed. Another way is to calculate the skewness and the kurtosis. These are two parameters of the distribution, like the average, the expected value, the variance. There is also the skewness and the kurtosis. The skewness tells you whether the distribution is shifted to the as a left tail or a right tail. You note that the normal distribution is perfectly symmetric, so both tails, the left tail and the right tail, are equal. If your distribution is skewed, it means that one of the two tails is fatter, is bigger than the other. Okay. Kurtosis, instead, tells you how flat or peaky, pointy, your distribution is. If kurtosis is negative, it means that your distribution is too flat. If it is 0, your distribution is perfectly normal. If it is positive, it's too pointy, like this one. Okay, let's see for the variable we have. How to do it? Well, it's in the descriptive statistics. Year of birth, options, skewness and kurtosis. You don't need anything else, so you remove everything else. Skewness and kurtosis. Let's see. Skewness is -6. It means that it has a big left tail. In fact, you can see this thing here. It's part of the left tail, while there is no right tail. Okay. Kurtosis 57, it should be 0. Both should be 0. It's incredibly high. In fact, it's very peaky as a distribution. It has a high peak. The peak should arrive here. So these two numerical data confirm the idea we got from the histogram that this distribution is not normal. Other way to check for normal distribution, QQ-plot. Okay. It's a plot. You will see some points and a line. The points should be on the line. It's much easier to show to you than to explain. It's here, descriptive statistic QQ-plot. Year of birth, test distribution normal. The QQ-plot lets you test also for other distribution. For example, check whether it's exponential or log normal, or there is uniform even. So you may check also whether the distribution is uniform using the QQ-plot. Okay. So while the other two tests were only to check whether the distribution was normal. Okay. It's a rather strange test. It will display you two graphs. Skip the second, consider only the first. The points should be on the line. If they are far away from the line, it's not normal. In this case, they are far away from the line. We have the usual person here, which is very far away, and also the point should be more or less on the line. It's on the left here, on the right here, again on the left here, so it's definitely not normal. Until now, we have seen, however, only, let's say, qualitative decisions. So we look at numbers or at graph, and we take a qualitative decision. The Kolmogorov-Smirnov test, instead, is an official statistical test which gives you a significance, and so here you take a quantitative decision. The hypothesis is that the variable is normally distributed, or you can perform the test for a uniform distribution, exponential distribution, whatever. Okay. So this is your H0 hypothesis. It means that if significance is above 5%, you accept it, and you could say that the variable is normally distributed, or whatever distribution you have chosen. If significance is below 5%, you reject, and you are sure that it's not the distribution that you want. Let's see. Analyze. Non-parametric test, one sample. It's here. It seems strange, but the Kolmogorov-Smirnov test is a non-parametric test. Customize analysis. Fields. Please remove all the variables as usual, and take only the one you need, year of birth. Settings. Customize test. Kolmogorov-Smirnov. Go to options. Normal. You can check also for uniform and exponential and Poisson as you see. Okay. Leave use sample data. Okay, run. The distribution of year of birth is normal with mean and standard deviation blah blah blah. Significant 0, reject the null hypothesis. Means that you are sure that it's not normally distributed. So as you can see, checking for normality is rather easy. You have 4 tools. The first and the third are graphical tools. The second and the fourth are numerical tools. However, the second, it's a numerical qualitative tool. The fourth, the Kolmogorov-Smirnov test, is an official test. Okay. Moreover, with QQplot and Kolmogorov-Smirnov, you can also test for other distributions, typically uniform, exponential, etc., etc. While the first two ways lets you check only for normal distribution. Okay, you can do this easy test at home. Okay, it's very easy. It's the same we have done with birth year. You can do with other ones. You will probably discover that none of these are normally distributed. And you can do the test also for passed exams, for example. This has some possibilities of being normally distributed. Okay, until now we have seen all the statistics, and this was the funny part, even though probably many of you don't find it funny. And now let's go to the boring part, the technical part. How to handle data, how to modify data, how to work with data. It's more technical. I have decided to put it at the end, so you have already experience with SPSS once you start it. Okay, first of all, the menu data. The menu data, as I anticipated to you at the beginning, is a menu which is designed to work on the data in the entire structure. So you can here modify the structure and work on the data. While in the transform menu, you can work on the data row by row, so case by case. Here you can work globally on the data. We will talk about sort cases, split files, select cases, and weight cases. These are the easy submenus. There are many more complicated, such as merge file, aggregate, restructure, transpose. We will not talk about them. If you ever need to do complicated things on data, you can have here a brief sketch. Okay. Remember that you can do these things and check in the help what to do. Okay, sort cases is the easiest one. You simply sort the cases. So you want to sort the people by they are already sorted by ID, by passed exams ascending. Okay, in the output you will see only sort cases by exam ascending. However, your data, you can see, will be sorted 1, 2, 9, 10, 10, 10, 12. Okay, so very easy, nothing to say about it. Split file. Split file is a little more interesting. It lets you split the file in 2 or more groups, and you will still have one single file. Don't worry, you don't need to save several different files. Okay, so you will keep one single file, but this file will be internally split in such a way that all the statistics that you do and all the graphs that you plot are divided by groups. For example, suppose I want to carry on an analysis which checks for the difference which confront male and female. In this case, I will split my file by sex. Okay, compare groups. You can split in 2 ways: compare group and organize output by groups. Compare groups will put the statistics and the graphs one next to the other, so you can easily compare them. Organize output by group is similar, but simply will plot all the output for male and then below all the output for female. Depends on what you want to do. If you want to compare the groups, you choose compare groups. If you simply want to split your output and you don't want to see the comparison, you choose the third one. Okay. The third one is a very good alternative to build several files. I've seen many of your colleagues which, whenever they want to do the thesis, if they have to check different things, they build different files, and so they have to repeat all the statistics several times. Instead, you can keep everything in a single file, organized out by groups, and so you perform the statistic once, and the SPSS will put its in the output several times. Let's see, however, how does compare groups work. Okay. Nothing has happened. Only SPSS has written sort cases by sex and split file layered by sex. Let's now, for example, draw an histogram of passed exams. Graph, chart builder, reset, histogram, passed exams. So a standard histogram for passed exams. Look in the output what happens. In the output you have the histogram for male and the histogram for female. Okay. So this is what happens. You have all your output split and the things are put one next to the other. Same thing for the statistics. If you perform a Kolmogorov-Smirnov test, you have the Kolmogorov-Smirnov test perform only on the male subject and then only on the female subject. Okay. The organized output by groups is very similar. The different thing is that this histogram probably will put a little more separated one with the other, but doesn't change too much. When you are satisfied and don't want to split your file again, so you want to join up everything, analyze all cases, do not create groups. Okay. And in the output you will see split file off. Okay. Remember also that here, when the file is splitted, you will see an indication. Okay. It's very useful. Let's see it. Split by university sex by sex. You can see. Well, let's see the indication. Split by sex. Okay, very important because it reminds you that the file is split. Analyze all cases. Okay. So, 2 very easy menus. Let's see select cases. Select cases. Sometimes you want to ignore some people because there may be people which don't go into your sample, so should not be in your sample because maybe they are too old, or maybe their questionnaires were too wrong. Okay. So there may be many reasons why you want to ignore some people. Okay. Instead of deleting the people from the file, which means that in case you change your mind, you will have to put them back manually, you can simply filter them out. So it's select cases. Usually you select all the cases. It means that you do everything on all the cases. If you check if condition is satisfied, okay, if, and for example I select passed exams larger or equal to 20, okay, continue, you can say if exams larger or equal to 20, it means that I will insert in my sample only the people whose special exams, for whom the special exams are at least 20. Okay. You can see the filter on appears. It means that you are filtering your data. You see that some people have been crossed. These are the people whose special exams, where are the special exams? Here, are less than 20. Others are not crossed. You see other people crossed here. Okay. So in this way I have filtered out the people with too few special exams, maybe because I want to concentrate my analysis on the others. From now on, whatever statistical analysis or graph you do will be done only on the selected people, so only on these people. These other people have been filtered out. At the exam, please pay attention. If I say please filter out the male people, it means that you must include only the female people. Okay. So in this case, at the exam, I will say please filter out people who have less than 20 exams. Or I can say please insert in your sample only people who have more or equal to 20 exams. Okay. So pay attention whether I say filter out or select. Many people confuse it. I say filter out male people and I instead select the male people. Okay, now every statistic you will do will consider only the other ones. Okay. If you want to remove the filter, very easy. All cases. And filter off. Okay, so select cases is a very good alternative. Please remember always to check filter out unselected cases, because if you choose delete unselected cases, it means that these people will be removed. So this is not what we want. Moreover, don't worry if a new variable appears. You can see a new variable. It's a technical variable needed only by SPSS. You don't need to touch it. Leave it alone. And don't worry about what is written here. Okay, because what is important for the filter is what you see here. Okay. Currently the filter is off because you don't see it anymore. So these are 4 really easy things. Let's go to the 4th one, weight cases. Weight cases let you, it's here, you can see the symbol, lets you weight your cases. Many times the cases that you have do not represent a single person, but maybe they represent several people. Suppose, for example, you're building a questionnaires on families, so each case is a family. Each case that you have does not represent one person, but represents more than one person. So in this case, you may want to weight your cases by the number of components of your family. Clearly, a family with 5 components will be worth more than a family with 1 component. Okay. It will be worth 5. Okay. So you will use in this case the components of the family as a weight. Here we could use the passed exams as a weight. Okay. If you use the passed exams as a weight, first of all you will see weight by exams appearing here. You will see weight on here. Weight on. Okay. It means that every person will be counted as much times as his exam. So this person will be considered as 1 person, but this person will be considered as 20 person, and this person as 55 people. Okay. So the weight cases does not only overweight some people and underweight others, but it also increases your sample, because now your sample size, if you, for example, calculate, let's calculate a very simple thing, reset, year of birth, descriptive statistics, you can see n now is 4322. It means that your sample size has exploded. Okay. So if you want to weight your sample, you can use whatever variable is more suitable. Okay, but pay attention that also your sample size will increase. This has a big effect on all the statistical test. Okay, it's not something that should be done if these cases do not really represent more people. Okay, because with 4322 sample size, your test will go much better than with 300 as we have. Okay, so these are 4 easy things to do. They modify the global structure. Let's instead go to transform, which modifies case by case your data. So it works only within case. So don't expect the transform to calculate an average of a variable, because it's not able to calculate the average of a variable over all the cases. Okay. The first and easy thing is to record menu. It's here. It's split in 2 parts, record into same variable and record into different variable. They are very similar. We will do the record into different variable because it's the safest. Okay. Record into same variable, you're going to change the current variable, so it's not safe. Suppose now, for example, that I tell you, please take let's see, university grade. Let's open and ask university grade, and decide that very low and low go to 1, average and good go to 2, and very good goes to 3. Okay. Currently very low is 1 and low is 2, average is 3, good is 4, and very good is 5. So I'm asking you to record your variable, so change the coding of your variable. 1 and 2 become 1, 3 and 4 becomes 2, and 5 becomes 3. For example, this can be a label such as small, average, very good opinion, bad opinion. Okay, so we also assign labels to the new variable. So we scale university grade, build a new variable, let's call it grade 2, with this scaling here, with these new categories. Okay, how to do it? Transform, record into different variable, university grade. Please remember to put here the name of the variable, grade 2. The label is not necessary. Now click on change. It's an often forgotten thing. You must click on change until you see grade 2 here, otherwise nothing works. Old and new values. Value 1, new value 1, add. Value 2, new value 1, add. Value 3, new value 2, add. Value 4, new value 2, add. And value 5, new value 3, add. So this is the rule to change it. 1 becomes 1, 2 becomes 1, 3 becomes 2, 4 becomes 2, and 5 becomes 3. Don't forget the missing values. You can decide that 9, which was my missing value, remains 9. Okay. Alternatively, you can say system and user missing, so all the missing values that we have, both the system and both the user missing, becomes, you can say 9, or you can decide that it becomes system missing. Okay. This means all the missing values, so both my missing value, so number 9, as well as the system missing value, so the little dot, becomes. So if at the exam I don't specify what happens to missing value, do what you want. Okay. The important thing is that you take care of them. Okay. Otherwise, if I specify missing user missing value should remain 9, you write like this. Okay. And system missing value should remain system missing value. Okay. Okay, let's discuss a little bit on this thing here. This is a possible alternative, one-to-one. Okay. Another alternative, let's remove everything, could be range 1 through 2 becomes 1. 3 through 4 becomes 2. And 5 becomes 3. It is also more easy to read. Okay, 1 to 2, 3 to 4, and 5. Okay, continue. Okay. Oops. Unfortunately, probably I have forgotten the weight on. Yes, I've forgotten the weight on, so remove the weight and redo it, because transfer recording to different variable. Okay. Let's see. Okay, now if at exam I specify this thing, I would like also to see the labels. So you go to variable view, you go to new variable, it's not scale, it's ordinal, its values 1, bad opinion, 2, average opinion, 3, what was 3? Very good opinion. Okay, no decimal digits, 1, okay. Save with a different name because I don't want to. Okay. And you can see here. Okay, let's do other examples. I may ask you to, let's see what we have. Okay, degree course, this is the typical change. So, student of the master degree course, which was the 3 and the 4, should go to master. Student of the bachelor, so 1, 2, and 5, should go to bachelor. So 3 and 4 go to master, and we choose for master number 2. 1, 2, and 5 should go to bachelor. We choose number 1. Okay, 5 it's other, so we are not sure. Let's do like this. And 5 missing and system missing should go to the new missing, which will be 9. Okay. So this is our rule. Let's do it. Transform recording to different variable. Degree course. Reset. Degree course. Degree type. Degree type. Change all the new values. Value. Let's see. 3 and 4 go to master. So range 3 to 4 go to master, which is 2. 1 and 2 to bachelor. 1 to 2 to bachelor. 1. Okay. Unfortunately, all the business studies will go into missing. So 5 will be 9, which we will record later as missing, and system and user missing again 9. Okay. Another alternative here could be the following. you decide what happens to 3, 4 and to 1, 2, and all other values, so don't forget that you have also all other values, go to 9. Okay. Continue. Okay. Let's see. Degree type. Variable view. We have to fix the variable. So it's not scale, it's nominal. 1 bachelor, 2 master, 9 missing, it's 9. Okay, I think we have everything. Yes. Is there any master degree student? Yes, some are here. Okay. Now, suppose I ask you to do the following. Group variable year of birth. How to group a variable? For example, born before 1970, one old, born from 1971 to 1980. Okay, I include also myself in the old people, so nobody gets offended. Born after from 1981 to 1988, 3 young. Born after 1989, 4 very young. Okay, so very easy. It's a recording, but now the variable that we record, it's not an ordinal or a nominal variable, it's a scale variable. So whenever you record a scale variable, you typically take the scale variable and produce an ordinal variable. You can see year of birth, here it's scale, but what we get at the end, it's just an ordinal variable. Okay, this is called grouping. So you group your variable into bins. Usually it's something which doesn't have too much meaning in statistics, because you have a wonderful scale variable and you reduce it to an ordinal variable, but many people do it, especially because in this way you can apply tests which are suited for nominal variables. Okay, let's do it. Analyze, transform, record into different variable, reset, year of birth, birth 2, year of birth, let's call it age category, change all the new values. Okay, while it's very clear that here you should do like this, and here you should do like this. Okay, well, what to do here? Please, in cases like this, born before 1970, do not do 1700 just to be sure, 1970. Okay, now it's here lowest through value 1970. It means that from the lowest number you don't know which one, but SPSS can calculate it. Okay, 1. Same thing. Oops, no, I've committed the typical mistake of not clicking add and clicking continue instead. Same thing for the other, highest through, so 1989 for add. Okay, so value through highest. Well, if you have any system or user missing, let's send them into system missing. Okay, I didn't specify anything, so okay, continue. Okay, you can see your new variable, it's here. Let's put the labels, the appropriate labels. 1 old, 2 average, 3 young, 4 very. Okay, and no, there's no missing here because we have decided the system missing, it's ordinal. Okay. Wonderful. Just a comment. What happens if you forget some people? So suppose, for example, I forget these people here. Okay. I have lowest to 70, 71 to 80, 81 to 88. Okay. And I forget to consider the people born after 88. Maybe because I don't believe there are any, or simply because I forget. So what happens if you forget a category? Inter-encode into different variables. In case you forget to include some people, these people will be automatically set to system missing. Okay. SPSS doesn't know what to do and will set them to system missing. So if you forget anybody, he will be set automatically to system missing. Let's do it. So I've forgotten the last category. Okay. Oops. Okay, I need first of all to remove the variable and then to redo it. Okay. Let's see what happens. You can see several system missing. Okay, these are the people which have forgotten. Okay. The menu recording to same variable, it's really identical. You can see all the new values. It's really identical. With, first of all, you don't need to specify the new variable name because you overwrite the old variable. It's very dangerous. Pay attention when using it because you are overwriting the existing variable. So the old values will be deleted. Okay, the new values will be applied. So first thing to remember, you don't need another variable name, obviously. Second thing, what happens if you do not specify a category? So you forget about somebody. If you forget some cases, luckily, in this menu, so in the recording to same variable, the forgotten people are not put to system missing, but the forgotten people remain with the value they originally had. Okay. So there is an advantage in using recording to same variable that the people you do not include in your recording remain with the previous value. So if you only want to change the value of some people and don't want to touch the value of other people, you could use recording to same variable. The people you do not include into this schema will remain with the original value. Okay. This is different from here, where the people that you do not include in your schema will be assigned system missing, so they don't remain with the same value. Okay. If you want them to remain with the same value, you should select all other values, copy old values. Okay. In fact, you can see that here you don't have all other values, copy old values, because you don't need to copy the old values. The people that you forget automatically remain with their original value. Different tool that we have is the compute variable tool. The compute variable tool instead is in charge of doing real mathematical operation on new variables. So you can add two variables or do whatever you want. Suppose, for example, that now I ask you to build a new variable called birth2, which contains simply the year of birth multiplied by 3. So it's just a stupid variable. So birth2 contains the year of birth multiplied by 3. Transform compute. Birth2. If you want, you can specify the type and label. Okay. It will be equal to year of birth multiplied by 3. Okay. You press OK. Birth2 already exists probably, so let's use birth3. Here you have a brief sketch compute birth 3 equal birth by 3. Let's see. Here birth 3, year of birth multiplied by 3. So very simple and nothing. So compute is very simple if you use it in this way. You can obviously, you are free to use a lot of arithmetical operation, the natural logarithm, okay, the exponential, the square root. Okay. So for example, exam 3, the logarithm, this is the logarithm in base 10, and this is the logarithm in base e, logarithm of passed exams. Okay. Here the logarithm of passed exams. For those people who have passed exams missing, clearly the logarithm is missing. Same thing if there were people whose number of passed exams were 0, the logarithm will be missing because the logarithm of 0 doesn't exist. Okay, now let's go to more complicated things. For example, suppose I ask you, build a new variable exams 4 equal to if student is male, a logarithm of exams. If student is female, logarithm of exams plus 3. So we give 3 more to female. Okay, how can we do this thing here? Let's see. Transfer compute variable. There are 2 ways to do the following task. The first, click on reset. It's always a good idea to click on reset. Exam 4. The first is the following. Can you see that there is an if here? You click on it, if, include if case satisfies condition, sex equal 0. So I am now a sort of selecting, temporary selection. I'm temporarily selecting all the student whose sex is male. Continue. So you can see if sex 0 is written, you must always pay special attention to what is written here, because if you forget to click on reset, SPSS will remember what was written here previously. So ln of passed exams. Now you click OK, and you do the first part of your task. You can see here it's written if sex equal to 0, exam 4 equal ln of exam, execute. So you can check. You can see that for the male, who are at the beginning, the female are in the second part, exam 4 has been calculated. For the female, currently there is nothing calculated. So the people who are not selected with your if, for the moment, have not been calculated. But don't worry, let's write plus 3, and let's click on if, select equal 1. Continue. So now, for only the people who with sex equal to 1, exam 4 is equal to logarithm of exam plus 3. What happens to the other? The other will remain unchanged. Okay. So it's like they recode into the same variable. The other people will remain unchanged. So you press OK. SPSS, however, is warning that the variable already exists. But it's exactly what we want to do, change the variable which already exists, only for the female people. Okay. Let's see. In fact, you can see that for the female people, we have the values. Clearly, if either sex or exams is missing, the final result will be missing, will be system missing. So this is the first possibility. Let's see the second possibility. The second possibility is much more compact and, according to my opinion, also much clearer. okay, but probably it's less straightforward. Click on reset. Let's call it exam for bis. Look what I write. I write open parentheses. I leave some spaces just for readability. It's not necessary. Sex equal 0 multiplied by ln of exams plus sex equal 1 multiplied by open parentheses ln of exams plus 3. Okay, look what I've written. I have put okay, I have put some logical expression. Let's put it in Word, otherwise we will. Okay, I have put some logical expressions such as sex equal to 0 and sex equal to 1 into a mathematical formula. In no standard mathematics, this would not make sense, but in computer science this makes sense. Computers interpret this as a true-false value. So sex equal to 0 can be either true or false. If it is false, it will be assigned a value of 0. If it is true, it will be assigned a value of 1. This means that when student is male, it will become 1 by logarithm of exams plus 0 by logarithm of exams plus 3. Okay. Which means logarithm of exams. On the other hand, when student is female, it will be 0 by logarithm of exams plus 1 by logarithm of exams plus 3, which means logarithm of exams plus 3. So this is a little trick to say, do consider this part when sex is equal to 0 and do not consider it when sex is equal to something else. Same thing here, do consider this part when sex is equal to 1 and do not consider it when sex is equal to when sex is something else. So this is a trick to make the expression much more compact. Let's see, press OK, and you can check yourself that exam for bis is identical to exam 4. But it has been done in only one step. Well, for sex it's not a major advantage, you can do it in 2 steps. But imagine I tell you to use a variable, which a categorical variable, so a nominal variable, which has 7 categories. You will need to build the if 7 times. It's a little boring. It's much faster to do it here. Okay, for example, suppose that I ask you, build a variable exam5 equal to exam if student likes statistics, 3 by exam if student likes computer science, exam divided by the square root of year of birth if student likes law, etc, etc. Okay, let's do 2 by exam in all other cases. Okay, in this case, well, it's a little boring using the if. It's much faster to do reset exam5 favorite, what is favorite, equal 1 by exams, okay, plus favorite equal 2 by, let's see, 3 by exams, plus favorite equal 3 by which was exams divided by the square root of birth plus favorite larger than 3. So you can also put logical expression with inequalities by exams or 2 by exams. I put here a lot of parentheses which are not really necessary. For example, these parentheses are not necessary, these parentheses are not necessary, these parentheses are not necessary. But I like to put them to make you clearly understand which are the parts of our expression. Okay, so you can see you can put also logical expression with inequalities. Pay attention, however, that when you use such tool and also when you use the if, the conditions may not overlap. For example, if you put here something as this will create chaos, because for students who like law, number 3, well, this is true and this is true. So you will have this and this added together. So you are creating chaos. So it's much better to put conditions which clearly do not overlap. Okay. So let's see. This is the do not delete the log because I needed to see what you have done. Okay, this is the another thing that you can put inside are the and, this one, and the or. In SPSS, AND is equal to this symbol here, and OR is equal to this symbol here. Another thing, in SPSS, different is this symbol here. So this symbol here in SPSS is different. Pay attention, because usually difference is, in many other computer applications, difference is this symbol here. Okay. In SPSS, it's this symbol here. It's an old program. You can use, however, also AND OR. For example, here you could have done something like favorite equal to 4 or favorite equal to 5 or favorite equal to 6 by 2 by exams. In this case, you are excluding the favorite equal to 7. To those people, the value of exam 5 will be equal to 0. All the people who are not included in the expression, if you look, for those people, 0 plus 0 plus 0 plus 0 makes 0. So you can use also the OR expression. In case at exam the expression required is a little complicated, pay attention to the OR, to the usage of OR and AND. If you are unsure, use as much parentheses as possible, as in this case here. You can see it doesn't change anything, but now I'm very sure that SPSS understands what I want to do. Okay? And doesn't make for or favorite, which is nonsense. Okay. Cancel. So you can use also logical operators, and there is a smart usage of equalities and inequalities in SPSS. Finally, I would like to tell you about the usage of mean function, because many of you really do disasters with this function. There is a function, reset, in the statistical menu called mean. Many of you are firmly convinced that if you do something like this, A, B, C, D, E equal mean of exams, you will have the average of variable exams. This is completely wrong for 2 reasons. First of all, it will be a very stupid usage, because A, B, C, D, E is a variable, so it's different for every person. If we set it equal to the average of exams, which is a single number, this does not make sense, or better, it's totally useless. Okay? But second reason, I told you, this menu, the transform menu, can do only horizontal operations. It's clearly written here. Can do only horizontal operation. This means that you are not able to calculate the average of a variable, which is clearly a vertical operation because you must sum up all the cases and divide by the number of cases. So if you instead carefully read here what exactly does min do, you will discover that is not exactly what you do. Min returns the arithmetic mean of its argument. Okay. The function requires 2 or more arguments. Okay, so it means that if you calculate something like this, min, year of birth, comma, first year of elementary school, here the function will calculate for every person the average between his year of birth and his first year of elementary school. Okay, it's a little nonsense. Probably it's the age when the person was 3 years old. Okay, okay, let's see. So you can see it's the average between 2 variables. So the function min does calculate averages, but calculates average between or among variables, not among cases. Okay, so it's the average. For example, if you have income of January, income of February, income of March, income of April, etc., etc., and you want to calculate the average monthly income, you could use birth of income January, income February, income March, etc., etc. So it's an average of variables. It's not an average of numbers. Sorry, of cases. Okay, same thing for sum. Okay, you sum up variables with sum. Okay, so doing a sum of year of birth and first year of elementary school. Okay, this is exactly identical to doing. Okay, doesn't calculate the sum of all the cases. Calculates sum of variables. Okay. Okay, we stop here.